All right, so we're adding on to the quadratic inequalities section. Today, we're going to be talking about absolute value inequalities. And so this would be an example of what we might be talking about. Sorry, give me just a second here. So let's say we had the absolute value of x minus 4 is less than or equal to 5. So we are going to take an algebraic approach to doing this. And then I'll show you visually what's happening graphically. But absolute value means distance from 0. Okay. So to do these absolute value inequalities, I'm going to write some stuff down that you don't need to write down, but just to try to give you a visual of what is happening. Let's imagine we don't know what is underneath that green block, okay? But we do know that we want that stuff that's underneath the green blob to be less than 5 units away from 0. So if you think of a number line, here's 0, and if you want 5 units to the right and 5 units to the left, anything that is more than 5 units, I'm sorry, I said more than, scratch that, less than 5 units away, because we are less than or equal to, so I'm sorry, we want the green blob to be shorter than 5 units away from 0. So that means that if here's 0 and it's less than 5 units away from 0, it can only be in that region. If it gets out here, it's more than 5 units away. If it gets out here, it's more than 5 units away. We don't want that stuff. We only want it to be in this region here. And so that's how we're going to set up our absolute value inequality equations. We're going to write 2 of them because we want it to be to the right of -5 and to the left of +5. So this you should write down. So once we have this problem, we would say that x minus 4 has to be greater than or equal to -5, and x minus 4 must be less than or equal to +5. And when it happens, this is assuring this is happening, and this is assuring this is happening, okay? And so this is the work I would expect you to be doing to solve this. And so then we just want to solve this inequality. I just move the 4 over, so I get x is greater than or equal to -1, and x is less than or equal to 9. And so in interval notation then, numbers bigger than or equal to -1 and less than 9, that would be in between 1 and 9. And that would be our solution set. And so the stuff on the left side of that line is what you should have written down. This I just wrote to kind of give you an idea as to how I came up with these 2 equations. I know that, sometimes you might say, well, you just make one +5, one -5, and switch the signs. Yes, that's true, but it's better to really understand exactly what's going on. And another way to look at this is think about what we know about absolute value graphs. Remember, absolute value is the V graph. And so that means we have the V graph. Remember, that moves it to the right 4. So if I took that graph and moved it to the right 4, and this question is saying, well, when is that then less than 5? Well, let's say 5 is here, and the graph is less than 5 there. It's from -1 to +9. Okay, so again, visually if you think of it as a graph, That's why we have those two boundary points. All right, let me give you another example. Go back to my blue here. So let's say we now have the absolute value of x plus 1 is greater than 7. So now I want this green blob to be more than 7 units away from 0. So I'll draw some stuff over here that you don't have to draw, but if we had a number line, here's 0, here's 7 units to the right, and here's 7 units to the left. If we want this to be more than 7 units away from 0, it would have to be either be here or here. And that's what our two equations are going to be. It's going to be less than -7 and greater than +7. So our two equations, we would say, this you should write down, that x plus 1 is less than -7. That's showing this area here. And x plus 1 is greater than +7. That's showing that area there. Once we have our two equations, we just want to solve those two things. So x is less than -8, or x is greater than 6. Now notice our answer has two regions, right? Stuff that's less than -8 and stuff that's greater than 6. Those are in two different spots. So when we write our answer, we would say this would be everything from -infinity to -8, exclusive because it's not equal to, union, exclusive, from 6 to infinity.
How do you know when it's supposed to be with the infinity?
Yeah, the question is, how do you know when it's supposed to be with the infinities or without them? That's why I think it's a really good idea to think of it this way and this way. If you are going less than, that means you have a finite area, okay? Your answer is going to be in one finite area. And if it's in one area, that means that it's going to have those two boundary points. As opposed to if you're looking at greater than, well, if you're looking at distances greater than, that means you have an infinite area here and an infinite area here. And that's where you have your infinite boundaries there. Okay. And also, if you're thinking of it in terms of a graph, you know, we have a V-shaped graph, move to the left 1. So a V-shaped graph, move to the left 1. And when is that bigger than 7? Well, if 7 is here, it's bigger than 7 here and here. We have two different areas. And so those are going to go to infinity and to negative infinity, to the right and to the left. Yes. When to use brackets and when to use parentheses. Yes. In this case, I used a parenthesis because I did not want to include the boundary point because there was not an equal sign underneath. If there was an equal sign underneath, we would make it a bracket. So for example, up here, there was an equal sign underneath, which means we want to include the boundary point. All right, great question, Scott.
How do you know when to make it like negative infinity to like -8 and then with the union?
Yeah. If you're going to need a union if you have two areas where your answers could be. And you don't need a union if there's only one area. So if you have, in this case, a distance less than 5, well, if you think about it in a number line, if you're going less than 5, that's all in one area. Therefore, we did not need a union. As opposed to the second one where we want a distance more than 7. Well, if it's more than 7 to the right, that would be here. And more than 7 to the left, that would be there. You have two areas. So that's where you need a union for your two areas. All right, really good questions. Anything else? All right, now that concept is about it, except the algebra can get a little bit tougher. But the idea of making those two equations is really the essence of what we're doing. So let me give you another example, which will be a little bit harder, but it'll only be harder in terms of the algebra. So let's say we have 2 times the absolute value of x plus 2 minus 5 is greater than or equal to 23. So we have 2 times the absolute value of x plus 2 minus 5 is greater than or equal to 23. Well, the only difference between this and the previous problems is I have all this junk attached to it, and I have to get rid of that. So I'm just going to get the absolute value by itself by moving this guy over, moving the -5 over, and moving that over by dividing by 2. So first thing I'll do is add 5 to both sides. So I have 2 times the absolute value of x plus 2 is greater than or equal to 28. Okay, I just added 5 to both sides. Now we'll divide both sides by 2. So the absolute value of x plus 2 is greater than or equal to 14. And now it's just like the problems that we were previously doing, where the absolute value is by itself. So it's a lot like this one, because you're talking about distances more than or equal to 14 away from 0. So on a number line, this is 14 to the right, this is 14 to the left. We want this thing to be over there or less than -14. For that to be over there, it would be greater than +14. Those are going to be our two equations. All right, x plus 2 is less than or equal to -14. And x plus 2 is greater than or equal to +14. And so we just solve both those. And notice we have two regions. So we're going to need a union within our answer, because we want numbers that are less than -16 or greater than or equal to 12. So in interval notation, it would be from -infinity to -16, inclusive because of the equal sign, union, inclusive, from 12, infinity. All right, I'm going to put one more up there. I'm going to let you work on it for a couple minutes, and then I'll go over it so that we can all do that together. So the last example, let's do 3 times the absolute value of x plus 1 plus 7 is less than 16. So take a couple minutes, work on that, and we'll go over that together in just a couple minutes. All right, so let's go over this. We want to get the absolute value by itself. So I'll subtract 7 from both sides first. So we have 3 times the absolute value of x plus 1 is less than 9. Then divide both sides by 3. The absolute value of x plus 1 is less than 3. So now we want distances less than 3 units away from 0. So if it's less than 3 units away from 0, 0, here's 3 to the right, here's 3 to the left, and less than 3 units away would be within there. So my two equations are that x plus 1 has to be greater than negative 3. Let's be to the right, negative 3. And x plus 1 has to be less than positive 3. So we solve those. I have x is greater than negative 4, and x is less than 2. And that is one region exclusive from negative 4 to positive 2. All right, any questions? Well, you guys at home?